For this problem, we're asked to find the composition of two functions and then find the domain of the new composed function. So we have f of x is equal to 7 over x minus 4, and also g of x is equal to 2 over x. We want to find f of g of x, and then we want to find the domain of f of g. So f of g of x is really f of g of x. So let's start off working a little bit toward our domain. In order to find the domain of this composed function, first we have to consider the domain of g of x. So the domain of g of x, if we look at it, g of x is 2 over x. It's a rational expression. Anytime we have a rational expression, that means we cannot divide by 0. If we let x equal 0, that would create 0 in the denominator, so x equals 0 is the value we have to exclude from the domain. So we're going to start off by excluding the value 0. Now there may be more values that we have to restrict in a few minutes, but let's start off with this. So let's find f of g of x. That's f of g of x. That means I'm going to substitute whatever g of x is everywhere I see an x in f of x. So that's really 7 over, I'm substituting g of x in for x, g of x minus 4. And since g of x is really 2 over x, I can replace that with g of x right here. 7 divided by 2 over x minus 4. Now notice we have a complex fraction. We can pretty easily simplify that by looking at the denominators. We have a denominator of x. This 4 has just a denominator of 1, and so does the 7. Really just has a denominator of 1. An easy way to simplify a complex fraction is to multiply the entire numerator and the entire denominator by what the least common multiple of all the denominators are. And in this case it would be x. So when we simplify this complex fraction in the numerator, we just have x times 7, or 7x. And in the denominator, x times 2 over x just gives us 2 minus 4x. So this is our composed function. F of g of x is equal to 7x over 2 minus 4x. Now, I said we needed to talk just a little bit more about the domain. With our new composed function, we also have to consider any value that creates a 0 in the denominator. And the reason I wrote this step right here where I'm putting the red arrow like this is because I want to find out what makes the denominator 0. So the denominator is 0 anytime g of x minus 4 is equal to 0. Well, g of x is really 2 over x. So anytime 2 over x minus 4 is equal to 0, our new composed function would have a denominator of 0. This is an easy problem to solve. Let's add 4 to both sides and we get 2 over x is equal to 4. We can multiply both sides of this equation by x and we'll get 2 is equal to 4x. And then if I divide both sides by 4, I get that x is equal to 2 over 4, or 1/2. So x equals 1/2 is now another value that can make the denominator of the composed function 0. So we also need to exclude that from the domain. So x cannot equal 0, and also x cannot equal 1/2. I'm going to do one more thing here, and I'm just going to write this domain in interval notation like I sometimes do. So the domain would be the interval from negative infinity all the way to the first value I exclude is 0, union 0 to positive 1/2, union 1/2 to infinity.